Hello everyone. Today we are discussing the next topic that is nothing but in Hadoop file systems, how we can design of Hadoop file systems, and we can see the Hadoop file systems architecture. What I meant to say now, design of Hadoop file systems. Today we are discussing the topic, and we can learn about the Hadoop file system architecture, how it will be, which nodes they are performed, and what operation will be run there. We can study about that. Okay, first of all, we have to learn about the Hadoop file system. What is a Hadoop? Hadoop is an open source distributed file system framework. Okay, for we want storing for processing of a huge amount of data sets with clusters of commodity hardware. It is the main aim of Hadoop. Now we can study about the design of a Hadoop file system. It has a master or slave architecture containing a single name node. It containing a single name node as the master and a number of data nodes as slaves is nothing but workers. Okay, Hadoop file system has a master or slave architecture. It containing a single name node as the master and a number of data nodes. These are as slaves, nothing but workers. We want to store a file in this architecture, and Hadoop file system splits the file into fixed sized blocks. The file system, Hadoop file system splits the file into fixed size blocks. For example, 64 MB, and it stores them on data nodes. Okay, now we can see what is a Hadoop file system. In the sense, the main theme, in the sense, it is a file system designed for storing a very large files with streaming data access patterns. Okay, in the sense, the streaming, the flow of data access patterns. Okay, something paradigms running on clusters of commodity hardware. It's nothing, it is a file system designed for storing a very large amounts of files on data sets with streaming data access patterns and running on clusters of commodity hardware. Now we can see let's examine this statement in more detail. Okay, here we have to look at this diagram. The figure illustrates you the architecture model of a Hadoop file system. What architecture model of Hadoop file system is shown below. Now all of you look at this diagram. In Hadoop file system architecture, we have name nodes. What is name node, what is metadata, and what the client will do the operation, what is a data node, what is a replication. You have to learn about each and everything in detailed further slide. Okay, this is the architecture. In architecture, the client will do and send something, and then the name node will do, and it blocks some operations and to send to the data nodes. The data nodes will be blocks is there. It should be replicated. How the mechanism will be run at the Hadoop file system architecture, so we can learn now. Okay, look at this, all of you. Here what the shows the mapping of blocks. Okay, now continue. The mapping of blocks to data nodes. You can see the HDFS architecture. At that diagram, we have data nodes at below. Okay, that data nodes, the mapping of blocks to data nodes is determined by the name node. Okay, it is the data nodes is determined by the name node. So the name node in nothing but a master. Okay, single name node is said to be already is a master. It and also manages the file systems metadata and namespace. What is a metadata? The data about data is nothing but metadata and a namespace. Okay, what I meant to say, in the sense, the mapping of blocks to data nodes is determined by the name node. The name node is nothing but master. It also manages the file systems metadata and as well as namespace. The metadata refers to all the information stored by a file system. Okay, all the information, it is stored by a file system that is needed for overall management of all files. Okay, that is needed for overall management of all files. And then we have to take for example name node. In the metadata, it stores all information regarding the location of input splits or blocks in all data nodes. So here we have to look at this. Each data node and usually a single node in a cluster, and it manages the storage attached to the node. So each data node, it is responsible for storing and retrieving its file blocks. What I meant to say in the sense, each data node is usually a single node in a cluster and manages the storage attached to the node. So here each data node, it is responsible for storing and retrieving its file blocks. So the mapping of blocks to data nodes is determined by the name node. The name node is nothing but master. It also manages the file systems metadata as well as namespace. Here what does metadata refers to? All the information stored by a file system that is needed for overall management of all files. Okay, that is nothing but what I meant to say, metadata. It refers all the information stored by a file system that is needed for overall management of all files. It is nothing but a metadata. Already I said you, once again I have to repeat these points. Each data node is usually a single node in a cluster and it manages the storage attached to the node. So the each node is responsible for storing and retrieving its file blocks. Okay, this is the example. Now we can learn about important specifically we can design at Hadoop file system. Okay, what is we can see Hadoop file system is a specially designed file system. What system? It is a specially designed file system for we want to storing a huge amounts of data sets with streaming access points, and running on clusters of commodity hardware. Okay, and it has some following elements we have to learn about that. First one is a name node. What the name node says, you have to visit it clearly. Name node. What is a name node? Let us see what is meant. What does it exactly? The name node specifies that hardware what it should be done at the task. Now okay, the name node is the commodity hardware that contains the GNU or Linux operating system and the name node software. What the name node said, it is the commodity hardware that contains the Linux operating system and the name node software. Even it contains the name node software as well as Linux operating system. So the system having the name node, what that system having? The system having the name node, what it acts? It acts as the master server. It's a single name node. It acts as the master server and it does the following task. What it does the following task here? We have mentioned 3 points A, B, C. First of all, we have to listen A. It manages the file system namespace and the metadata for all the files and directories in the tree. What I said in the sense, we have to manage the file system, entirely file system namespace we have to manage, and the metadata for all the files and directories in the tree we have to manage that the file system namespace, metadata for all the files and directories, especially in the tree. Now we have seen the B point. It regulates client access to file. The client, the user must access the files. It to regulates clients access those files. Okay, now coming to the C, it also executes file system operations such as what I mean to say here, the master server, it also executes the file system operations. What operations it should execute? File system operations such as renaming, we have to give, once again we have to give some name, renaming, and closing and opening a file and directories. This is the concept of a name node, what it does exactly. And coming to the data node, what I meant to say now, data node, what the data node will do exactly. Okay, data node, the data node is a commodity hardware, it having the Linux operating system and data node software. What it does, the data node is nothing but it is a commodity hardware, it's running on clusters of commodity hardware that contains Linux operating system, as well as even it contain data node software. What node? Data node software. Okay, what does the data node manages, how it utilizes, what the purpose of that we can see now. Data nodes manage the data storage of their file system. What exactly? The data storage of their file system. Data nodes perform read write operations on the file system as per client request. Now listen carefully. As per client request, the data nodes manages the data storage of their file system. The data nodes perform read write operations on the file systems as per the client said, the client request. Okay, now coming to listen, the next one is nothing but secondary name node. What ma? Secondary name, what does it mean? A secondary name node, already we discussed name node, data node, and now we can learn about secondary node. What node? Secondary. What node we have to learn about? Secondary name node. Okay, what does it exactly? We can see no secondary name node. Secondary name node, and which despite its name does not act as a name node. It does not act, listen carefully. Secondary name node, which despite its name does not act as a name node. It doesn't acting on a name node. It's variously despite of that one. Okay, it's a main role. What the main role? What the main responsibility of that one secondary name node, in the sense to periodically merge the namespace image with the edit log. Okay, what they said, to periodically merge the namespace image with the edit log. We want to prevent the edit log from becoming too large. Okay, what they said, to periodically merge the namespace image with the edit log, we want to prevent the edit log from becoming too large. It's the main role of that. Now coming to what does the secondary name node uses, what does it usually, what does the purpose? Usually it runs on a separate physical machine. What ma? It runs on a separate physical mission, since it requires plenty of CPU and as much memory as the name node to perform the merge. What I meant to say, in the sense, the secondary name node usually runs on a separate usually it runs on a separate physical mission, and during at that time past years, it requires a plenty of CPUs. Okay, it requires a plenty of CPU and as much memory, and as so much memory as the name node to perform the links, in the sense to perform the merge operation. Okay, now we can state the secondary name node, it lags that of the primary, and so in the event of a total failure of the primary, data loss is almost certain. What I meant to say, in the sense, what that is stateful, in the sense, the state of the secondary name node lacks that of the primary, and so in the event of total failure of the primary data should be lost. It is almost certainly done there. This is the concept of design of Hadoop file systems, and we can learn about the Hadoop file system architecture also. Later we can discuss the Hadoop file system features. Thank you.